This is an introduction to the Pyroraptor, which is a USB to I2C SPI GPIO and UART bridge. So you hook it up through the USB cable to the PC, put the drivers in, and our nice graphic interface, user interface for the Pyroraptor, and you can test and play around with I2C devices, scan them, individually select them, read and write to them. We'll show that in this video. So here it is. This is the device. Now we have all these switches here, which is very convenient. Instead of using jumpers, for example, a switch would allow you to operate at 5 volts, or you can operate at 3.3 volts. We also have a switch that will select whether we pull up with 10K or 2.2 kilo ohm resistors, and that's very important depending on the speed of the bus. We do have the Mullex connectors here. Let's take a good look at those. So the Mullex connectors have 4 pins, and I2C we support 4 pins. Basically VDD, which is, for example, 5 volts, ground, and data and clock line. We'll explain those in a minute. So you have the option of connecting through these Mullex connectors, which are very rugged, and you can also use those as 25mm posts. We have these DF11 connectors here, 2 of them. These are very small. We use these a lot to miniaturize our electronics, and they're all keyed, and we'll show that in a minute when we connect these pot meters to the Pyroraptor. And so therefore the Pyroraptor right out of the box supports 4 devices. It's got support for 4 devices on a bus, and of course we provide another bus on our devices so you can chain some more up. So what we're going to do is connect the Pyroraptor to the PC through the USB cable, and notice what's going to happen. So the minute we connect it, you see that blinking LED. So that means the driver recognized the board, and on the board we have a ARM Cortex processor, and it is running and blinking that LED. All is fine. That's a clear indication that the driver was connected. Now what I'm going to do is connect a pot meter to the Pyroraptor. Now the pot meter is this device here. Let's show that. And basically it has a meter and 2 dials which are connected to potentiometers. On the back side you'll see our circuit from IONOTRONICS. It has an NXP chip in there which supports 4-channel ADC and a DAC, and it is a I2C slave. So it supports a digital to analog converter and 4 analog to digital converter channels. And very conveniently we have 2 I2C connectors here, so we can chain these guys, put more devices on the bus, and we have connectors for the 4 analog signals. And these switches here allow us to select the address for the device. So instead of using cumbersome jumpers, we can immediately set the address with the switches, and therefore we don't get any conflicts, especially where you use a number of these. So we have connected 2 pot meters to the Pyroraptor, and you can see that in one of them the blue LED is turned on, which means the device is being powered by the Pyroraptor. And of course the pot meter supports 4 ADC channels, and these potentiometers at the front allow us to change the voltage going to the ADC. We also have this indicator here which is full scale at 5 volts. So this is connected to the digital to analog converter, and when the digital to analog converter puts out 5 volts you'll get full scale. The reason for that is we have a precision 100 ohm resistor in series with 5 volts, which gives you 50 microamps. So this is nice. This is a great device for working with I2C and also building up consoles where you want to control things like a robot and move its position with these dials. Very convenient. So we have this guy connected to the Pyroraptor. We have another one also connected to the Pyroraptor, and it is using a different address than the one we just showed. So basically we are going to look at the I2C bus to find out which devices are on the bus. So to do that we are going to go to our graphical interface here, Okay, so here we show the graphical interface. Now remember, we have two devices hooked up to the I2C bus. So using the Pyroraptor Graphical Interface, which is written in Java, we can scan for devices. So if we scan for devices, we see that we have two devices on the I2C bus. So that is a very important feature of our tool. If you are dealing with I2C devices, just hook them up to the Pyroraptor, launch our Pyroraptor Graphical Interface, and scan the bus, and here we see two devices. Let's go ahead and zoom in a little bit. You can see the two devices right there, and they correspond to the pot meters down here. Okay, so let's go back to the interface. So essentially we're able to scan the I2C bus. Now even more importantly, we can talk to the I2C bus by writing data to the devices or reading from the devices. So in this case, we're going to take the device 4E, select it, and you'll notice that its address ends up in the selected field right over here. Now I'm going to zoom into this area. So we selected the device and it ends up in the selected field here. Now if I select the other device, we get 4B or 4E. So here we have scanned the I2C bus. In fact, let's do that again. And you'll see that we get two devices on the bus. We are going to select one of them, and we are going to show how to write to an I2C device. So basically you scan the bus, select it, and you see that field got populated. And here we're showing two nice setups, one for writing to an I2C device and one for reading from an I2C device. Of course, we write in hexadecimal, so in this case we're writing 2 bytes, and the values are 40 and FF in hexadecimal. 40 basically tells the ADC DAC I2C slave that the next byte is going to be the value of the digital to analog converter. Now, conveniently, our digital to analog converter is connected to that nice meter, so we're going to see some action here. Okay, so now we're showing the Pyroraptor and the 2 meters, and we are going to write to one of the meters, which is 4E. Let's get ready for that. So we just scan the bus, select 4E again, and we're going to write the values 40 and FF to the meter. Now look at the meters and see which one changes to full scale. In fact, that will be the one that has an address of 4E. Let's go ahead and write, and you'll notice that the meter went to full scale. Let's go ahead and zoom in a little bit. You see that? And the other one is still at 0. So the next thing I'm going to do is, let's zoom out of here. You see the 2 meters. Let's go ahead and show what we're doing over here. Now in the field, notice that I've selected the device 4E. Let's go ahead and select the device 4B, and we will write the bytes to 4B and see if it goes to full scale. Okay, let's go down here, take a look at the meters. Alright, so I'm going to write to device 4B now. Let's go ahead and write, and it went to full scale. So we can individually write to the I2C devices on the bus, very convenient. We can also read from the I2C bus. So for example, on this particular meter, I'm going to go ahead and set the dials all the way to 0, and we are going to go to the graphical interface here, and we'll ask it to read to 4 bytes actually. So let's go ahead and read 4 bytes. We get all zeros, and that should be expected. Now I'm going to go on the dials and move them arbitrarily and go ahead and do a read, and you'll see that the values changed. Now in the previous command, when we set the DAC to 255, which was full scale, we also told it to set the channel to channel 0, so we'll be reading one of the channels. And so right now we've set everything to 0, and I'm going to do a read, You see it's all at 0. Then I'm going to take the dial all the way to full scale and then read the ADC, and you get FF. And you notice since we got 4 bytes, it'll just repeat. Now if I go and set it somewhere in the middle, somewhere, do another read, I get a different value. So you can see how easy it is to read from an I2C device, that convenient, as well as writing to an I2C device. So the next step is to show you some interesting action. We actually have set up the ADCs so that we have this set up here in the Pyroraptor. Take a look at that. And you can see that we have 4 meters. These meters are what we call Java beans that we have developed, and they allow us to monitor all 4 channels of the ADC simultaneously. So what we're going to do is down below we have some fields we can set up, and we are going to set up the device that we want to read to, which is 4E. So we're going to look at device 4E, and we are going to read it at a 300 millisecond interval. Now, we can also change the value of the DAC with a slider. So we're going to get some interesting action going on here. Let's go to these meters here and start this guy. So now we're running, and I'm going to change the dials. So here we have the meter. Let's take a look at that. Right here we have the meter, and I have the dials. So I'm going to go ahead and change the dials, and you'll see the meters change. There we go. Full scale, midpoint, 0, full scale. So we're changing the dials. So basically we're reading, in this case, 2 channels simultaneously. So this is great. You can actually monitor 4 voltages simultaneously, and that's excellent. And in fact, if you're looking at something like for an accelerometer with 3 analog channels for X, Y, and Z, you can visualize them all simultaneously, which is great. We have a video on YouTube that shows that. Now the next step is we are going to add another pot meter. Here we go. So we got another pot meter here, and here's its I2C wires connection, and we're going to connect it to the Pyroraptor. So we'll do that right now. Now, instead of hooking it up to the Pyroraptor, so here we zoomed out of the setup, so let's take a look at our pot meters here. And each pot meter on the back has 2 I2C connectors. So we can add another pot meter, this one, to the bus by simply connecting it to the other pot meter. So instead of going to the Pyroraptor, we can connect it directly to here. So I'm going to do that right now. Okay, so what I've done is connected this guy to the other pot meter, and what we want to do is see if the other device shows up on the I2C bus. So we're going to look at the I2C bus tab. We just click on that, and let's scan for devices. So let's go back up here and let's zoom in so you can see the scanning. So currently we're showing 2 devices, 4B and 4E. We've just added a 3rd pot meter, and we're going to scan for devices. And you see that the 3rd pot meter appeared, and its address is 4A. Take a look at that. So its address is 4A, and what we're going to do with that device is select it, and we are going to write this value to it. So let's see if it goes to full scale. So let's go ahead and take a look at the pot meter. So here we have all 3 pot meters, and what I'm going to do is do a write. Now look at the 3rd pot meter, which is the one we added, which is address at 4A. Let's go ahead and write and you should see the meter go to full scale. There you have it. So clearly showing our capability to scan an I2C bus. In fact, we scan buses with upwards of 10 devices, 20 devices on there with no problem whatsoever. We control robotic arms with, for example, 6 degrees of freedom, and each one individual I2C address. We have I2C slaves that implement the PWM control, and we also have rovers with multiple sensors, which you can scan the rover and find all the sensors appearing on your graphical interface here. So this is a very powerful tool for I2C work. So what I'm going to show next is this device, which is a laser range finder. It is connected through these 0.1 inch 25 mil posts, which is a lot of ways people connect devices to. So here's the device, and we have a nice cable, which I'm showing, which takes the nice compact small miniature 4-pin connector, the Hiroshi DF11 4-pin connector, and converts it to nice 25 mil post, so you can hook it up to your devices. So you get a device with 25 mil post, easy. We provide that cable. All you do is hook it up, and now we're going to plug this in to one of these meters and see if we can see this device show up on the I2C bus. So let's go ahead and do that. So what I've done here is, you can see the device right here. I've hooked it up to the pot meter. Remember, the pot meter does have another I2C bus connector, so now it's connected. And let's go ahead and scan the I2C bus. Let's go ahead and zoom in. Alright, so I'm going to go ahead and hit the scan button, and let's see if this device shows up and what its address is. There you go, its address is 29. So we have another device we've added. Conveniently, we're not going to run out of connectors for the I2C bus. So now you can see we can select this device and write and read from it. And it's a good way to exercise the device, get the data sheet, and look at all the registers and do things with it.